Okay, so I just stumbled upon this concept of tiny TPUs. I mean, they're basically reinvented versions of Google's original TPUs.
Right? It's fascinating how they're trying to democratize access to advanced hardware design, especially for beginners.
Totally. Like the idea that anyone, even someone who's just good at high school math, can dive into this world is pretty mind-blowing.
Exactly. They break down complex concepts like the processing elements into something more digestible.
Oh, for sure. So these processing elements, they do multiply accumulate operations every clock cycle, right?
Yes, and what's wild is that the incoming data is multiplied by a stored weight, then added to a partial sum.
Wait, so that means it's constantly building on previous calculations every cycle? That's super efficient.
Exactly. And the architecture uses a systolic array, which flows data in a grid. It's like a well-orchestrated dance.
Oh, wow, a dance. It's like each processing element passes the data along, right?
Yes, input flows horizontally while the partial sums move vertically. And during all this, the weights stay put.
That's really interesting because it helps with the overall speed of operations. I can't imagine the data management complexity.
Right? And they also rotate input matrices by 90 degrees to align with the systolic architecture.
Whoa, that's super clever. It's like fitting puzzle pieces in the right orientation to solve a bigger picture.
Exactly. And then they have a unified buffer for storing intermediate values, which sounds like a lifesaver.
A buffer? I can already see how chaotic it could get without one. What kind of data doesn't it handle?
It stores input matrices, weight matrices, and even the activation values for backpropagation.
That gives me chills, all that data passing through and being meticulously managed. What a feat!
And the control unit is fascinating, too. It has a 94-bit instruction width. Talk about precision.
94 bits. That's like an entire mini command center on a chip. What kind of commands are we talking about?
They control everything, from system mode switches to reading and writing address data. It's super detailed.
I can't even imagine coding that, but they seem to make it accessible with clear setups.
Absolutely. They break the setup into straightforward steps, even covering OS-specific processes.
How do I explain this? It's like they're inviting everyone to be a part of hardware design. So inclusive.
Yeah, and they're open source too, which really embodies that spirit of collaboration and learning.
Hold on, that changes everything. It's not just about the chips, it's about building a community.
Exactly. It's all about sharing knowledge and empowering people at various skill levels.
I never thought about it that way. Are there any other innovative things they've included?
Oh yes, they've even included ways to visualize data through waveform generation. How cool is that?
Wait, so you can actually see how the data flows in processes? That's fascinating for understanding.
Right? It makes debugging and learning way more intuitive, especially for those new to hardware.
I'm trying to picture this whole system in motion. So many layers of complexity.
And what's even crazier is how they plan to scale this up to larger dimensions, like 256 by 256.
Wait, really? That changes the game. Imagine the computations possible at that scale.
Exactly. It opens up new avenues for machine learning and data processing that we haven't even explored yet.
You know, this ends up being a really good example of how technology can be made accessible.
Absolutely. And with those basic math skills, anyone can contribute to the future of chip design.
So if we put all this together, it feels like we're on the verge of a hardware renaissance.
Totally. It really leaves you pondering the limits of innovation and learning in our tech landscape.
Exactly. I'm so glad we explored this. It's exciting to think about all we can build together.
And who knows, maybe the next groundbreaking TPU could be built by someone tuning in right now.
That thought is electrifying. I can't wait to see where this journey in chip design leads.
It's a thrilling time to be curious, and who knows what new discoveries lie just around the corner.
Yeah, and I'll be looking out for those 256 by 256 designs. Imagine the breakthroughs.
For sure. But for now, it seems we've both got a lot to think about and explore. What's next?
Well, I guess the real question is, how far can this newfound knowledge take us in the world of tech?
And that's where the adventure truly begins. Let's keep this curiosity alive.